Okay, in this video we will look at an example in which we have a RLC circuit. We have an RLC circuit. So here we want to determine the value of V out. Alright, want to find V out of the circuit here, so which is the voltage across the inductor. Right. So before that, okay, first we assume, in this case we will assume that the initial condition of the circuit is 0. Okay, and probably later on in different video we will look at how to solve the circuit if the circuit has initial condition. Okay, however, in this video we will assume that the initial condition is 0. So we want to find V out, which is the voltage across the inductor, 1 Henry inductor. Okay. So the first step to solve this is to transform. Okay, this is the very first step. In order to solve the circuit, we have to transform the circuit from time domain to S domain or frequency domain. Okay, we have to transform the circuit into S domain. So each component here, the voltage source, the resistor, the capacitor, and the inductor, all these components must be transformed into S domain. So the circuit itself is to be transformed into S domain. So if we look here, the voltage is 1 UT. Okay, so according to Laplace transformation table, 1 UT, alright, 1 UT is 1 over S in S domain. So if the circuit is the voltage is 2 UT, then this is 2 over S. Alright. Okay, next is, so this is the voltage source now in S domain. Next is the resistor. Okay, the resistor is still the same for S domain. Okay, 1 ohm in time domain is also 1 ohm in S domain. 5 ohm in time domain, also 5 ohm in S domain. Okay, so the resistor are still the same. Next is the capacitor or the inductor. Let's look at the inductor. 1 Henry. So what is the equation to transform inductor in time in S domain? So this is the equation: S times L. So L is 1, then 1 S times 1 is S, which is this, right? Okay. Next is the capacitor. So the capacitor here is 1 over 3 farad. So the equation to transform the capacitor into S domain is 1 over SC. Okay, it's 1 over SC. So C is 1 over 3. So therefore the capacitor in S domain is 3 over S. Right? 3 over S. Take note that these values are now in impedance. Right? S ohm. Alright. So now that we have finished the first step, which is to transform the circuit into S domain, we have the voltage as 1 over S, 1 ohm, 5 ohm, 3 over S, S for the inductor. Alright. So next, what is the step? Next step is to solve for the V out. Okay. Take note that now the V out is in S domain as well. Okay, instead of V out T, it is now V out S. So we can solve for V out S first. So in order to solve for V out, we need to use any available circuit law or rules. So you can use mesh, Thevenin, Norton, okay, whatever method is suitable to solve for that circuit. So in this case we will use the mesh method, which is here we will have first mesh I1, and then we have the second mesh I2 here. So if we use this method, we use the mesh method, then in order to get the V out, we can just simply multiply I2 with S. Okay, multiplication of I2 and S will give us the V out. So we have to find the I2 first. Okay, next is to find the I2. Before we can find I2, we have to find I1. So we now apply mesh analysis for mesh 1. Okay, take note on the direction of the current. So here this is 1 over S, this is the voltage source, this 1 over S equals to I1 times 1, I1 times 3 over S, and then don't forget I minus I2 times 3 over S, because here in this branch here we have I1 going this direction and then I2 going this direction, so that's why we have this minus I2 times 3 over S. Alright, so now we have solved for mesh 1. Now let's go to mesh number 2. So here mesh 2, right? Mesh 2, we don't have any voltage or current source, so it is 0 here. Then for this component, we have, now we are referring to I2, right? So now we have I1 in different direction, in the opposite direction. So that's why in that case the I1 is negative, right? Negative I1 times 3 over S. Okay, and then the rest is I2 times 3 over S, I2 times 5, I2 times S, right? Yes, I2 times 3 over S times 5 and times S. And then we can rearrange this to get this form, this condition, this equation, and then we can substitute I1 here into this equation, right? We can substitute I1 here. Right, to get this. Okay, this is the I1 that we have substitute, right? Sorry, including this as well. Yep. So this is I1. Okay, now we can see that the equation only has I2, so we can rearrange or reduce this equation to make it more simpler. Okay, so if we multiply this equation with 3s, then we can actually simplify everything to become this. Alright, and then we can rearrange this to become this, right? And then now we can get I2 so that we can solve for V out. So V out is basically S times I2, right? So V out is S times I2. Alright, next is, so this is the V out. S times F2, this is the V out. Alright, however, the answer is still not finished. This is not the answer because we have V out in S domain. What we want is V out in time domain. So in order to do that, in order to get V out in time domain, we have to inverse transform the value, right? We have to inverse transform V out S into V out T. So we can actually refer to the Laplace transformation table to do the inverse. However, we have to make sure that the equation is in the correct form so that we can refer to the table. So here, how we can rearrange this into this condition or this equation is basically, if we look at here, this is actually S2 plus 8S plus 16 plus 2, and then here you can actually change this to S plus 4 squared, right? So you have S plus 4 squared and plus 2. So here the form is now can be referred to the table, Laplace transformation table. Right, so if we look at Laplace transformation table, we can have we can transform into exponential negative 40, right? This is from here, and then sine square root of 2. Okay, so let's just look at the Laplace transformation table we have here. Okay, so this is the Laplace transformation table that we can refer to. Alright, so exponential minus at sine omega t is equals to omega over s plus a squared plus omega squared, right? So here omega s plus a squared plus omega squared, right? So here, to make it squared, you can just square root of this and then square the value. You get, now the omega is square root of 2. Then of course the value here, okay, the value here, since we don't have square root of 2, then we can put square root of 2 here, and of course to compensate that we have to put square root of 2 here, right? Put square root of 2 up here and then compensate it with square root of 2 here. So now we have square root of 2 on omega and omega here. So now you can inverse Laplace transform to get 3 over square root of 2 exponential minus 40, right? Which is this t sine square root 2 t. Okay, thank you.